Assalamualaikum everyone, welcome to mathematics, and we are doing A levels paper pure maths 1, paper code 9709, paper 13, May June 2025, and we are doing question number 4. So let's begin. Find the three terms in the expansion of 2 minus 3 over 2x whole power 5 in ascending power of x. Okay, so what we are supposed to do, first of all, we should be knowing what is binomial expansion. We have a plus b to the power n, and a plus b whole power n gives you nc0, a to the power n, b to the power 0. So normally we don't write these two because these both are equals to 1. So we normally write it as first term to be a to the power n plus nc1, a to the power n minus 1, b to the power 1 plus nc2, a to the power n minus 2 and b to the power 2. So these are your first three terms of the expansion. Now, secondly, what we will be doing is actually starting to solve this. For this, you must know what is a, what is b, and what is n in this particular expansion. So in your given term expression, you have a to be equals to 2, b is equals to minus 3 over 2x, and n is equals to 5. So now start solving it. So we have 2 minus 3 over 2x whole power 5 equals to 2 to the power 5 plus 5c1, 2 to the power 5 minus 1, and minus 3 over 2x to the power 1. We are taking b to be minus 3 over 2 because the standard is a plus b to the power n. Now for the third term, we will be writing 5c2, 2 to the power 5 minus 2, and minus 3 over 2x to the power 2. Now simplifying this, you can directly simplify this by the help of your calculator. Okay, only this step is important where you will show them by putting all the values in the correct format, and then you can directly solve with the calculator. So 2 to the power 5 is 32, 5c1 is 5. I am doing it manually. 2 to the power 5 minus 1, 2 to the power 5 minus 1 is 4. So 2 to the power 4 is 16. Then it gives you minus 3 over 2x plus 5c2 is 10. So 10, it will be better if we could have okay, 8 to the 5c2 is 10, 2 to the power 3 is 8, and then minus 3 over 2x whole square will give you 9 over 4 x square, positive x square. Okay, so and further simplifying will give you 32 minus 120x plus 180x squared. So this is all of your expansion of this bracket. Now we have to do part B of this question, and part B says use your answer to part A with a suitable value of x to find an approximation to 1.985 to the power 5. So firstly, we need to find a suitable value of x. Suitable value of x you can find. You can see this 2 minus 3 over 2 x should be equals to this 1.985 because this is whole power 5 both of them. So by equating them, you will be able to find the suitable value of x. So x comes out from this to be, if you take this on the other side, it will become positive, and then the other side comes here on this side will be 2 minus 1.985. 2 minus 1.985 is 0.015. 0.015, and then x becomes 2 over 3 times 0.015, and this will give you 0.01. So if x is equals to 0.01, then you can write it as 2 minus 3 over 2 times 0.01. That will give you equals to 1.985. So first we have found the suitable value of x. Now what we have to do is using your answer of part A. That means we already have expanded this into this form. So using this x value in the expanded form to get the approximate value. So when x is equals to 0.01, then 2 minus 3 over 2 times 0.01 whole power 5 will be equals to 1.985 whole power 5. Okay, this is equals to this, or you can substitute this in the expanded form. 32 minus 120 times 0.01 plus 180 times 0.01 square. Instead of writing it equals, it is approximate value because we are just taking a few terms. So 32 minus 1.2 plus 0.018. And solving this will give you 30.818. So this is your whole working for question number 4. First, you will expand it up to 3 terms by using the binomial formula, binomial expansion formula. Secondly, when we need to approximate, first you will find the suitable value of x, and that suitable value of x comes out to be 0.01 by equating the brackets, whatever is inside the bracket. Then when we find that x equals to 0.01, we substituted it in the expanded version in place of x. That gives you the approximate solution. I hope you understand it. Thank you.